Hey everyone, my name is Liam. We're going to be looking at our first little ALEKS tutorial. This is one that it's pretty easy to get wrong. It's a little frustrating. This is reading a measurement from an analog instrument. So in this case, we're just being asked what the length of this pencil is. And you might be asking yourself why this is important. Well, this is going to come up a lot in labs. You're going to want to make different measurements while you're in the lab, and it's important to know how precise to read your measurement. You don't want to guess what the value of your measurement is. You want to put down a value that is reasonable, something that you can make sense of. And so we'll get into a little bit of what I mean in this problem. So in this problem, we're given a pencil, and we are given a ruler that is measuring this pencil. And if we measure out here, we've got 6, right? This is 6 centimeters. And then in between, we have 1, 2, 3, 4, and 5 makes 7. So this one is 7 centimeters. Now, these little lines here, there's 5 of them, or there's 5 increments between each whole number value. So there's 5 increments between this 6 and this 7. And so, you know, just there's 10 sort of, you've got 6.1, 6.2, 6.3, etc. So that means that these lines indicate a fifth of that. So this is just 6.2 centimeters, this is 6.4, this is 6.6, and 6.8. So in this situation, what we can do is we can magnify. We always press magnify for these problems, and if you magnify it, you can see that our pencil comes down to the 6.2 centimeter mark. And so that's what we're going to put for this problem. If the pencil had come to this point, right in the middle, we'd put 6.1. That's pretty safe to say. But if the pencil had come, you know, closer to this point, it might be tempting to say that this would be 6.19 or something like that. But don't fall into that trap, especially with ALEKS, because that will be marked wrong. 6.19 is too accurate and would be incorrect in this situation. So you want to select the most reasonable value that you can clearly see, and in this case that is 6.2. So 6.2 is what you would enter for that one. So moving on to our next one. This one is a little bit more hard to see. So right now we have 0 and we have 0.1. And in between, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So we have 10 increments. So if we have 10 increments between 0 and 0.1, that means that every increment is going to be 0.01. So let's magnify. If we magnify, we see that we are getting, if this is 0.05, 1, 2, 3, we're closer to the 0.08 line here. Now, this is a little frustrating because if you look at this problem, it might be very tempting to say, okay, but this is a little bit past the 0.08 line, so, you know, maybe I could say that it was 0.081 or 0.082. But no, for this problem, I think what ALEKS is going for here is that it's trying to emphasize that you shouldn't be guessing. When you select a value, it should be pretty obvious what the value is. And if it's not obvious, you want to go with the next best choice. So this is not considered obviously 0.081 or 82. This is closest to the 0.08, and so that is the answer we go for in this case. It's a little frustrating, and it's very tempting to try and put something else, but for all intents and purposes, that will be marked wrong if you put anything other than 0.08. 0.08 is the answer to 2 decimal places. 2 decimal places. That's going to be your answer for this one. Okay, 0.08. Notice that in this one, we are also at 2 decimal places. Okay, so let's move on to the last sort of example that you're going to see. That is this one here. So we're given a graduated cylinder. This whole thing, in case you don't know, it'll be important to kind of know your lab instruments. This is a graduated cylinder. Okay, so we're given a graduated cylinder, and we want to measure what the volume of liquid is in this graduated cylinder. So if we look, it's a little difficult to see, but if we look, we have this sort of dip here, right? And so it's important that we measure at the bottom of this dip, okay? So this dip is called the meniscus. That is MENI and then SCUS. That is the meniscus, and we always want to measure from the bottom of that meniscus, the bottom of that dip. So if I erase my markings here, we can see that the bottom of this dip comes out to around there. So if this mark here is 80 milliliters and this mark here is 85 milliliters, and we're coming just below the 85 mark, then our safest answer is going to be 84 milliliters. All right, and don't forget to put the decimal. I know it seems redundant, but 84 on its own is not correct. It's very frustrating. I understand. I hated it at first, but you're going to have to get used to it. The dot here, that sets in stone that your sig fig, you have 2 sig figs, right? And, you know, yeah, 84 in and of itself is a 2 sig fig number. However, if instead of 84 you had 80 without a decimal place, well, now we have 1 sig fig. We can fix this by adding a dot in there. Now it is 2 sig figs. All right. So, yes, in this case, we come to just below 85 here, and so 84 is going to be our answer. And so, yeah, good luck. These are a little bit frustrating, but you'll get the hang of it eventually. Oh, yeah, and here's our magnified view in case we were curious. That comes out to about 84. All right, and the units are already put in there for you, so you would just enter 84 and then 1 decimal, or 1 decimal period. And that is that.